After we wrote the software for the MicroBlaze, it's time to move to the Zynq. Now the Zynq, again, it has an integrated interrupt controller, and like always, Xilinx provided us with examples. The drivers are here in the S here in the same location like we always used to. Xilinx Vitis version data embedded software, Xilinx processing IP lib drivers, and this one is the SCU-GIC. Again, we have here all the functions that we need. Here is the functions that I found. So the software for this one is exactly the same, but here we have two more stages. One, we need to set the interrupt controller parameters before we initialize. We have a lookup function. Then we initialize, we connect, and then we need to set the parameters, the interrupt parameters, and then we can enable them and initialize the exception table. So now we can start working on the Zynq. So I'll close all the unnecessary files here. I'll leave just the MicroBlaze, and we'll go and we'll generate again an application project. We need a new project because we're using a different CPU, so we can't use the old platform because it's for the MicroBlaze. So we'll go again to our XSA, this time we'll call the platform Zynq, and we'll call the project Zynq int software, and we'll address it to Cortex-9.0, and we'll create an empty application. And we'll make a new file. We'll call it Zynq int software.c, and we can start writing. Again, first the includes. We'll close those two. Now here we see again the parameters, the printf, and the XSU-GIC with all the functions for the interrupt controller, the internal Zynq interrupt controller, and the two structs. Here they are. First, we need the struct for the pointer to the interrupt controller. So again, static, and we'll leave it with the name int_c. Like we did in the MicroBlaze. Again, I'll take from the MicroBlaze. I'll take the declaration of the two head handlers, and I'll actually take the handlers themselves, but we'll do a minor change. But instead of using a GPIO, I will use the printf, because in the Zynq we have and a UART. So I'll call this one first interrupt number and we'll add the count. And this one will be the second. That's it. Now for the main. We use the main and we close it. And here we have the status like we had in the MicroBlaze, and we have the interrupt controller config struct to enable us to move parameters from the XSA to the interrupt controller pointer. So first we need to find the interrupt controller in the XSA parameters. So we have a function here, lookup, which return an interrupt controller config struct. I'll copy this with remark. Now what we need is the device number. Now the device number, as we know, we have the X parameters, and in the X parameters we have the X parameter PS, which is for the processing system. And here in our interrupt controller section, here we have the ID. So here is the ID. So this shows the lookup function, which interrupt controller we're referring to. Now here we take it for, this is a pointer, so we'll take the pointer and we'll add an if statement if fails. If it fails. So now we have all the parameters in this struct. Next, we'll need to initialize it. This is something familiar that we did before. And we can use the same remark from here. And this struct uses status, and we can use the same if fail statement, and we can look at what we need. Here we need XSCUGIC, the interrupt controller pointer. So we'll use it as a pointer like we did before, and then we use the config struct, and we need the base address. The base address is part of the config struct. We can see it here inside the config struct. We have a CPU base address, so it's a part of the config struct and we're just gonna use it. And we initialized the interrupt controller. Next, we need to set the triggers. Again, we have a function For each interrupt we need to configure the parameters of the trigger. So get trigger, set trigger. Now this is a void. So we don't need the status. We need the interrupt controller pointer. We need the ID. Now, as we know from the PS, we connected the interrupt to the first and the second of the FPGA IDs. So this is the ID for the first, and later we'll put the second. And we need priority. We can use priority for the interrupt from 0 to 248. So these are the only interrupts we have in the system, so we'll put them at 0 as highest. And the trigger here is writhing edge sensitivity. So we can use just 3. So we'll add it at 3 for the writhing edge. And the same for the second interrupt. The remark. And that's it. We configured the interrupts, and now we need to connect. Again, for connection we have a function here. Again, it returns a value, so we use the status and the fail if. And again, we need the interrupt controller pointer, the ID for the right interrupt, and we need the handler. Here is the handler. This is our handler. For the input of the handler, we actually can use the interrupt control pointer, which will tell him where to go. This is for the first interrupt with the first handler, and this is the second. Okay, we finished this, and now we need to enable the interrupts. Again, another void function. The interrupt controller pointer and the interrupt ID. For the first and the second. So our interrupt controller is ready. Now we need to start to initialize the exception table. So in the interrupt controller header, we have the exception header. Like we did in the MicroBlaze, we have the initialize, this is actually the same functions that we had earlier in the MicroBlaze. They're exactly the same. The only difference is that the register function first has the ID, it's the same. Now the handler is a little different. Is a handler for the Zynq. Here we had a handler for the interrupt controller, and here we have a handler for the Zynq. Here it is, and it gets the interrupt controller pointer, so we add the interrupt controller pointer. And we can take it from here. We see that the enable function is the same function, but now we're in the Zynq. Now we're in the Zynq, but it's the same function. So that's it. We initialized the exception table, and the only thing that left is the while loop. You can just take the while loop from our MicroBlaze and write it here. So this is the software for the Zynq. We get the parameters for the interrupt controller, we initialize it, we set the trigger for each interrupt, we connect the interrupts to their handlers, we enable the interrupts, and we set the exception table. And that's it. We're ready to compile this. And we compiled it. And the only thing left to do is to run it. This I will do in the last video of this tutorial. Thank you and goodbye.